Let me continue with the example about the population. The initial population is 200 people at the beginning, and the relative growth rate is 50% per year. So P of 4 represents the population at year 4. So when I replace 4 instead of T, I get this number. Now, what if the question asks, how fast is the population growing at year 4? So whenever we ask for some kind of velocity, how fast it's growing, or we may be asked what is the growth rate at year 4, that will be something equivalent. What will be the growth rate? Remember that I have to take the derivative. So if I'm taking the derivative of P of t, I'm going to get P prime of t, and that would be 200 e to the 0.5t times the derivative of 0.5t, which is 0.5. Now, if you remember, when I reorder this, the only thing that I'm going to get here is 0.5 in front, and then this is just the same as P of t. So the growth rate for this function is the same as 0.5 times the current population. So how fast is it growing at the 4th year? So P prime of 4 will be 0.5 times the population at 4. So the only thing I have to do is multiply by 0.5 my population for that year, and that will be whatever you get for a number, and that's gonna be on persons, or people per year. So you're gonna get 738.9 people per year. So let's just talk about what is the difference between growth rate and relative growth rate. So growth rate is what we know for the instantaneous rate of change. The growth rate is the value of P prime of t, whereas the relative growth rate is the value that we have here as k in our equation. P of t equals P sub 0 e to the kt is this value. What are the units of growth rate? If we're talking about a population per year, then the units would be people, or number of persons per year. And the units of relative growth rate is going to be either a decimal. If it's 0.5, then it will be 0.5 per year. Or if we're talking about percents, then it will be 50% per year. But you know that when we talk about percents, we talk about percents of what? We always talk about percents of something that we consider a whole. So in this case, if we look at this would be 50% of the current population. So that's why this is called relative growth rate, because it depends on the current population. So please do not get confused whenever we use growth rate and relative growth rate. Going back to our previous graph, I can have for 4 years, this is the population, and if I do on the calculator 0.5 times the current population, I'm gonna get the tangent of the slope of the tangent line, which is also known as a gradient, and we saw that in the previous section. So 0.5 times 1,477 is 738.9. So what does that mean? It means that the population at this particular time is growing by 738 people. So I could sort of anticipate what would be the number of people by the 5th year. So if I add 1,477.8 plus the 738.9, then by the 5th year I should be somewhere around 2,216. So let's see what we actually have. Let's compare these two numbers. So by the 5th year, according to the model, we have 2,400. So this is not a bad estimate, but remember, how come these two answers don't match if I'm saying in the 4th year that the population is growing this fast? because as soon as we go away from the year 4 and we the time takes the value of 4.1 or 4.2 or 4.3, the growth rate is going to change instantly because the growth rate depends on the current population. So that's why that number is not accurate. But I think it's it is safe to assume that it's going to be about this much, and it is pretty close. Now let's check our understanding so far what we know from these exponential functions and the growth rate. It says, suppose that p of t is 368 e to the g of t. It's an increasing function, so because it's increasing, I know that it's going to look like this. What, if anything, can be said about the number g? Well, I know that this is the relative growth rate, and it must be positive if I'm talking about an increasing function. So that's done. Number 2 says, consider the population model. In this case, instead of k, they're calling it r, but it doesn't matter what you call it. It says, write an equation that involves that number, p prime, and p of t. So I can just take the derivative of p of t, and that would be p prime of t equals initial population e to the rt times, remember to take the derivative of this, which is r. Now rearranging, this is r, p sub 0 e to the rt, and this is the original p of t that I had. So the derivative will be that. And it says, then describe the equation in words. Well, this is the growth rate is proportional to the current population. So I can write that in words. Number 3 says, suppose you're at a point on the graph of this function. So my graph looks like this at some point, where the y value is 481. I don't know my x value, but my y value is 481. It says, what is the current population size? So, well, all the y values in here are my current population, so I know it's 481. So this is 481 people. How fast is the population changing at that point? Well, I know that the slope of the tangent line is going to be given by this number k times my current population. So I know that 62% of 481 will be how fast the population is growing at that point. And I find that with my calculator, and I answer my question. It says, consider the function p of t equals this. Suppose that p of t measures a population of animals, and that time is measured in weeks. What's the growth rate when the current population has size 599? So all I have to do is multiply my relative growth rate by 599, and that will be the growth rate for this population. Express this current growth rate rounded to the nearest whole number and include units. Remember, growth rate is going to have units. This is population of animals, so it would be animals over weeks. Number 5 says, let p of t 821 e to the 0.54t. Find p of 17. So I just have to replace, and that will be the population at time equals 0.7 time equals 17. I don't know if that would be, if that would be weeks or months or whatever. Number 6 says, fill the blanks. P prime is called the derivative of p. P prime gives the of the graph of p. So it gives the slope of the tangent line of the graph of p. How should p prime of t be read out loud? Just like that, p prime of t. Number 8, consider the function p of t. What's the relative growth rate? And I can read that of here, 0.72, or you can write 72% per whatever units of time. Number 9 says, choose all appropriate words that describe the function. So I know that the number k, the constant k, the relative growth rate is positive, so I know it's increasing. So because it's increasing, it's exponential growth. Number 10 says describe the relationship between this graph and that graph. So I know that the only thing that is changing, this one would be increasing and this one will be decreasing. And not only that, but they are a reflection over the y-axis. Number 11, consider this function. Suppose that times is measuring months. What's the relative growth rate? So the growth rate would be 2.53 per month, or you can say 253% per month. And that's it. So now give it a try to reading the slides, and probably would be more understandable after the previous explanations. But let's do example 1 to see another way of solving problems like this. So we have the population at 2 different years. So just to make our calculations easier, I'm gonna define t as the time in years from 1950, because that's where the oldest record I have. And I'm gonna do p of t as the number of people in millions, so that I don't have to carry a lot of zeros with my calculations. So I know that p of 0 is 2,560, and I know that p of 10 is 3,040. So since I know p of 0, this is the one that we call p sub 0 in our formula. So when I write it, I write p of t equals 2,560 e to the kt. And it's asking us what is the relative growth rate? So they're asking us for k. Where it says assume that the growth rate is proportional to the population size, that is exactly the piece that we need to know in order to set up an equation like this. Because remember, we're going to use base e for population as long as this is true. So now I just have to replace. They give me p of 10. P of 10 is 2,560 e to the 10k. And that should be equal to 3,040. So now I'm just going to solve this equation for k. I divide both sides by 2,560. And then I have e to the 10k equals this division. And now, how do I solve for k? K is not being multiplied or divided. K is an exponent. So I have to do the inverse of e to the something. So the inverse, remember, that is natural log. So I'm going to apply natural log to this side, and I'm going to apply natural log to this other side. So the natural log of e, that cancels out, and the 10k appears. And now the only thing that I have to do is divide both sides by 10. So when I do that, I have k, and I can do that directly on the calculator. Natural log of 3,040 divided by 2,560, and that divided by 10. And that's approximately, oh, I have something wrong here. Oh, I didn't. I put an extra parenthesis, I think. Okay, now it's better. So I have k is approximately 0.017, which is 1.7% per year.